hier hätte das ja, was denn da jetzt hier vorne drauf auf dem?
Wenn du einen Output aufmachst.
Achso, okay, sind die richtigen. Achso, stimmt, nur wenn ich einen Output.
Sticky Mirrors und der Output wäre dann auf dem.
Stimmt, ja.
Der Orange ist dann.
Macht Sinn.
Das ist der Ethernet.
Ja. Okay. Oh, okay, well, wait for a second. So I think you've done enough scripting for today, maybe? I think I won't actually, if I remember right, there's not one single line of, there's not even an expression now in this, so there's no more typing. It's one of those things that when you work with Touch Designer after doing a lot of scripting, I encourage everybody to try to do a nice project without any scripting right after. While we just wait for one more person to show up, a nice exercise. Let's see. A nice exercise to do, if you feel like it, there's a short overview over. Oh, it's gonna start playing. I should change that. There's a nice workshop from MuTech Japan where we go over all kinds of feedback effects and how to make pretty pictures with feedback. So this also doesn't require any scripting. So if you feel like on a nice Sunday, like tomorrow, you want to rather look at create some pretty pictures or some strange effects with feedback loops only, then check out this feedback techniques workshop that's on the YouTube channel as well. Lots of fun. Anyway, so Bullet. Well, literally what we'll build next is, or let me introduce it like this. Bullet is an open source framework for rigid and soft body physics, and after quite some time trying to decide what we're going to do about the need of physics, and seeing things like Vincent Houzet's, not sure if you're familiar with Vincent Houzet. He wonder if he has this on his videos here. He very early on actually made a chop that implemented the Bullet engine. And at that point we kind of had enough and thought, okay, looks like we need to videos. Nope. The internet broke. Monomango. I can try this. Let's see. Geht nicht, ne? Yeah. Anyway, Vincent Houzet had this very early on. You might recognize this video. He had this little box mounted to a stepper motor, and he was controlling the stepper motor with Arduino, and then the projection basically knew how to project, so was a little bit tracked, projecting onto this box, and inside the box he had a little simulation of rocks falling on each other, which essentially he did with this bullet engine, the bullet shop that he wrote himself, which you can still find also on GitHub when you look up his repository. And one of our programmers, Eric, he was tasked with creating this new group of components that are mapped here under this Dynamics tab. And currently we do have a couple. We have actor, bullet solver, constraint, force, and impulse force components that cover most parts of what you could do with rigid body physics or rigid body dynamics. Meaning, basically, what we currently solve for is anything that doesn't deform itself. So you cannot, with this setup, you cannot simulate a ball deforming when it hits the ground, but you can simulate just a box falling onto the ground and maybe like tumbling or something like that. And so for this little lesson here, what we'll do is we'll try to build a little game, which is the, I think they're actually called Breakout. Right. You might remember those. It's a little paddle, and you have all these boxes above you, and you have a paddle and a ball, and then the ball shoots up, and whichever other box the ball hits, this box is being deleted, and your task is to catch the ball with the little paddle, and then get rid of all the boxes in your scene. So, well, you will see that there's probably some things to be still included in Touch Designer, and the way that you work with such a physics system might be a little bit strange, but the good thing is we don't need any scripting. It's all node-based completely. And we can think about the system of this breakout game. We have a couple actors in this system. We have a box which constrains the movement of the ball, so the ball can bounce off a wall. This would be our box. And then we have a paddle to bounce the ball off from as well, and that is movable. Then we have the ball itself, which flies around, and we have those little boxes that we want to delete, essentially, when hitting them. When the ball collides with a box, delete the box. So we can start with just creating the surrounding box, maybe, as a first step. And for that, we'll get a sub, and we'll take the box sub, and we'll set this box up to a certain size. I chose 16 by 9, and I'll give it a depth of 1, so that a ball can actually live in it. And yeah, and we'll make this an actor. Usually when you're setting up a rendered scene now, you would choose a geometry component, but instead of a geometry component, let's make this an actor. So, I'm not sure if you're familiar with what I just did. I often right-click on the output of a sub and just select the component, the geometry component, or in this case an actor, to set up my render scene, which helps me, I don't have to wire up everything inside, and I don't have to, I actually do have to. Okay, so let's go inside the actor and set the render and the display flag of the out sub. Usually that would be prevented by placing the actor as a output to the box. So inside the actor 1, turn on the render and the display flag. Okay, what else do we need to render a scene? We've got an actor, we need a camera. So let's put down a camera. And maybe we need a light. That's always useful. And let's put down a render top. And then let's adjust the camera such that we see the whole box. So, well, we can just make it actually an orthographic camera. And the width of my box is 16. So I should set up the ortho width to be 16 so that I see the whole box. And this will be my output. I'll put a null on it because I always do that, and have a look at it like that. And now let's have a look at these parameters that we get for an actor. One of the most important ones here is the kinematic state of this actor. And if you click on the menu, you can choose between static and dynamic. Now, what does that mean? A dynamic actor is something that is influenced by outer forces or by other forces. So if I would have gravity in my system, then a dynamic actor would be affected by gravity and just fall down. A static actor doesn't. It has infinite mass. It doesn't get affected by any of these outer forces. So as my box doesn't move, and I don't want my box to be moved by anything, I'm making this a static actor. Next, let's have a look at the properties. And here I can set, there's 3 parameters now enabled. If this would be a dynamic actor, you would see more parameters enabled. But for the static actor, you have 3 things enabled: friction, rolling friction, and restitution. Now, friction is basically describes how another actor, or how 2 actors influence each other when they hit each other, because there's friction between them. So it's going to change the way that if I hit a ball and then there's at a certain angle, then perhaps the ball starts spinning because there's friction. And the amount of spin that it gets, or the amount of friction that there is, will also change the flight path, like how it is being reflected off the wall. The rolling friction, I honestly don't have a good explanation for you yet, and there's no help available. And restitution is a factor on how much the force is being reflected as well. Like if you have a restitution of 0, that means all the force is being absorbed, or all the energy is being absorbed, and so anything hitting this box here will just doesn't have any energy anymore. It's just static then. If I set the restitution to 1, that would mean that all of the energy is being preserved, so I don't have any loss of energy in that case. And this is certainly something that we want. We want some friction, so the ball can spin, and you can actually spin the ball with the pedal perhaps later. And the restitution of 1, yes, it should always just keep its energy. You don't want it to lose energy. And our second part that we can try right away would be our ball. And our ball is just a sphere sub. So let's find a sphere sub and connect it as an actor. So component actor. Again, to render it in the scene, we should go inside it and turn the render and the display flag on. And now this ball is pretty big, so I'm just going to scale it down on the transform page of the actor to 15%, 0.15. That might have been a little bit small. weird. Really? This is one white. Why would
When
that?
do you want to use the scale, and when do you want to change the actual size
Of the sphere, of the sub? Generally speaking, if all the subs are being calculated on the CPU, so they're not very performant. And what's happening though when you bring them into the render stage essentially by rendering them from a geo component, that means they have been uploaded to the GPU. So anything you do with the translate, rotate, scale on the geo components or on the actor components parameters will be done on the GPU and is extremely fast. It has no, you don't get any frame problems with that, especially when you start animating it. That's the main thing.
Okay, so you can animate scale.
Actually not, but out of habit.
Okay. Because otherwise it won't cook. Otherwise.
No, if I start,
Anyway,
it wouldn't. This whole system doesn't it won't cook. But out of habit, I'm doing it there. Yeah, there could be other reasons why you would do it in subs. This would depend on what you're actually doing. And okay, so now I have two actors, and that's great. But I don't necessarily have a system right now. So what I need now is something that solves for the whole thing, that starts processing this whole system here. And for that we have a bullet solver component. So if I place a bullet solver component, then by default actually it already comes with a little network inside. And there's an initialization button and there's a start simulation button. So if I click the start simulation button, you see that I have a donut falling onto a rectangle. This is because these two actors are inside of this bullet solver already. You can initialize the whole thing again, start it again. You have control over the speed if you want to have it go really fast. Oops, I didn't mean to change that. Or you can make it behave really, really slow. Then it's falling extremely slow. There's gravity, a global gravity for the system that you can define here. You can define if this is a two-dimensional or a three-dimensional or even a one-dimensional solver. And actually for our case, because we just deal in 2 dimensions essentially, we'll switch this into a 2D solver. Yeah?
If this torus would be a square, then the rolling friction makes sense because then it won't go off the platform.
Of the platform, yeah. I would have thought that general friction would do that as well, but I guess there's a finer distinction there, yeah. Okay, so we have it set to a 2D dimension here, and we don't want to look at the actors inside, but we want to look at our actors here that are parallel, that are siblings to the solver. So let's just change this actors parameter from /star to star. And let's turn off the render for the bullet solver. Now, why does this always disappear? This is weird. Let's also give this sphere a little bit of a material. We can give it a little Phong material, and to see it spinning, actually what's very useful is to give it a ramp top as a color map. And for the ramp, let's set the type to, let's set the interpolation to step and move the white into the middle so that we just have a black-white, well, not quite ramp, but color tone thing and apply this to the Phong, and then apply the Phong as a material to the actor. And I don't understand why this is not picking it up, but anyway, after all, we're working in experimental here. Might also have it in the back right now, but no.
Can you go back to the ramp form?
The ramp, what I changed is the interpolate notches I set to step, and then I pulled the white key. Oh yeah, it's just in the back to the center. Perhaps if I change the ramp to be vertical, yeah, now I get a better view of it. And you know what? I'm gonna try.
Can it be a bug? Mine is not the rendering anymore, the actors.
Sorry?
The actors are not rendered anymore in my...
Did you go inside the actor and turn on the... Yeah?
The render factor.
Let's see.
The move this one. It showed up, but then I added this one, and then it disappeared, and then I removed it, and then it's nothing there. Maybe I should restart it. Oh, no, it does. Yes, it's going now. Because it was just falling.
Yeah, I mean, there is certainly... you will find bugs in these builds. That's why we call them experimental. But it's a good idea to play around with it anyway. So, now, what should happen with our system if we started? We created the sphere as a dynamic actor. So what I expect now is that if in the bullet solver I start the simulation, the ball just falls down. But if I give the ball, and I just have to check one thing, I do not understand why my why this is not updating correctly. Why the size is not updating correctly. I have to try something here. I do not understand why it disappears.
Now inside your box.
This is relatively strange.
Inside your box.
Oh, yeah.
Oh, and my camera is outside the box. Well, that's stupid. Yes, thank you. the default camera is set at 5 units away, and our box I just made 1 unit deep. So maybe just by default, if I make my box deeper, like 10 units or something like that, I would actually see my sphere here correctly, and now I can size it down to, yeah, to some size that's actually sensible.
And the sphere should be in the box or on top of the box or in the box.
And the sphere is in the, should be inside the box, exactly.
Are we inside the box now?
And the camera is inside the box, as the box is set to a, the box is, or the camera with a default distance of 5 from the origin, and the box being set to a size of 10 in depth, 10 units or 11 or 12, is properly looking inside the box. So I'll set the restitution of the sphere to 1 as well. And if I start my simulation now, my sphere just disappears into somewhere, and we should check where it went. It should be in the box, yeah. I want to see my geometry viewer here. And somehow my sphere ended up on top of the box. So let's figure out why that is. We don't have a linear velocity, mass is 1, great. And I probably have to define my collision shapes. So this is another thing where how you define how these things are colliding with. You can have collision shapes that are concave, convex, or bounding boxes, etc. What I figured out would work best with the box as a collision shape is the compound, which basically tries to build out of multiple shapes a collision shape. And for the sphere, we'll keep it at convex, if I remember that correctly. Yes. Okay. So the box should have a collision shape of compound, and the sphere should be a convex hull. Now initializing it and starting it, I get actually the result that I wanted. And I just have this ball basically randomly jumping around. Not quite randomly. And I have my first little physics system in here.
I was always disappointed that it doesn't jump off the nose.
Sorry? Oh yeah. It definitely should jump off. Damn. Next time. So what would be our next steps? Let's have a look what else.
So are you inside the box with the camera? Or,
Yeah, exactly, because I set the... I told you to set the size of the box to 16 by 9 by 1, but the box size should be more something like 16 by 9 by 12 or something.
And then the camera is...
And because the default camera is positioned at a depth of 5, at that 5 units.
Okay, yeah.
So that was my mistake here. So you see what sometimes happens. Sometimes the ball just disappears, which is a good time to restart the whole thing and let it go again. But so let's have a look what we're getting, what kind of information we're getting from this. To retrieve any kind of information about the actor or the system, you can find a bullet solver chop. And this bullet solver chop can be connected to an actor, And it will return information about, there's an actor ID. If the actor is active, you get its transforms and rotates and its velocities. And the nice part about this is that, or the idea of this whole system is that I can take those transform and velocity channels, and I can actually use them again in this parameter feedback chop here, which we'll be looking at in a bit. What this means is that I can change on certain events. I can, or let's say if the velocity is decreasing of the whole thing, I will be able to check the velocity and clamp the velocity at a certain value, and then feed that back into the actor comp, overriding its new velocity essentially. So you can do a lot of things with that. You can, we'll be able, for all these boxes we can basically move them out of the way once they are collided with the ball. This will be all done via this feedback chop parameter here.
Do you need to specify a collision top on the box?
On the box, no.
Because mine just falls through.
Did you set the actor to be a compound shape? Compound collision shape? Sorry, you would see it here.
The box?
Yeah, the box
okay.
to compound collision.
Yeah. But the n is infinite, yeah?
Oh yeah, there is
Yeah.
No, it works.
So the next actor we need would be the paddle. So for the paddle, let's set up a little rectangle again, or a box. So get a box up, and I set the size of the box up to 1.6 by 0.3 by 0.05, although that's a bit small, but whatever. It doesn't really matter.
Should it not be as deep as the box? You could also jump away in that direction now.
Right, so it cannot jump into Z because we set the dimension for the solver to a 2D. So it's just solves in 2D. And this box again is an actor, but the box, when the box collides with something else, the paddle, if the paddle collides with the ball, we don't want the ball to be affected by we don't want the paddle to be affected by the ball, meaning that this box again should be a static actor. So let's right click on the output of the box and add an actor comp and set its kinematic state to static. And let's change the properties of it again to have the friction is fine, 0.5, and restitution 1. That's fine too. And inside the actor, we would have to turn on the render and the display flag again. Now let's also transform the paddle a little bit to the bottom and maybe give it some constant color so we can actually see it. Right now it's a little bit invisible here. So let's get a constant material and apply that to this actor and give it a color. It's pretty green is fitting. Okay, let's take blue. And now as this box has become part of the system, let's see if this works. Initialize the whole simulation, start it, And now my ball is bouncing off my pedal and then bouncing off my box. Yeah, restitution 1, friction 0.5.
How come it eventually runs out of steam if restitution is 1?
Does it run out of steam?
Yeah, it eventually slows down to nothing.
If it eventually still slows down, perhaps because of the friction, what we'll be doing is we'll be clamping the velocity so that it always has a minimum velocity. One fun thing you can try out here to see how the restitution works, or I'm not sure if it's that much fun, but if you basically set the pedal to a different restitution than the box, then you can try out what would happen when you do that. Unfortunately, we still have this problem that sometimes the ball actually goes through walls. We're trying to solve for that. Yeah.
Is that a software problem, or is that a problem that we need to figure out?
Sorry?
Is that like a bug, or is that something that we need to tweak?
No, it's something Touch Designer has to figure out. Yeah, nothing to tweak. I guess the steps, because with every, you calculate basically the new position with every step, and at certain speeds then or something, it falls, the distance travel falls in between where it's checking for collisions or something like that, and I'm not sure, it basically disappears.
It also has to do with the size of your walls.
Sorry?
It also has to do with the size of your walls.
And the
Now you
size,
have
yeah.
a box that's really small, so if you make it from walls that has more mass, let's say,
Yeah.
then it keeps it in.
We had, I talked to our developer and he said if I take like something in these unit sizes, it should be fine, but maybe I have to do 160, because it's centimeters or something, right?
Yeah.
Like if Bullet uses not units, but actual sizes, yeah. But, okay, so we've got our pedal. And last but not least, what we need is our little blocks. And these blocks we can build the same way as we use, like what we use instancing basically for. So let's create first a template for the box. So make a little box up. And the box up I set to 0.63. That didn't work. That's a comma. And 0.2. Nope. And yeah, a depth of, again, something like 0.06 or something, doesn't really matter. And we'll give this into an actor again. Component actor. And again, we have to go into the actor and turn on the display and render flag. And let's give it a material right away as well. I'll choose a constant material with some color.
Is turning on the render flag automatically something that should happen?
Yeah, this seems to be not, like usually if you put a sphere sub down, for example, and append a geometry,
Right.
then it does that. And so there's something, there's a little script that runs that does that, and apparently I have to fix that because that's under my domain. So I'll go back and fix that. Okay, so we have one little box here. and we can now we can instance this box many times to distribute it over the whole scene. So the nice thing is that also in the bullet system you can use instancing to create actors. You don't have to create 100 actors now, but taking a grid sub let's create a grid sub and let's set it to 15 rows and 20 columns and a size of 13 by 4 and maybe position it when I placed it 1 unit up, it worked kind of nicely, I think, right? Or did I transform this as well? No. Yeah. And now we'll use this grid as our instancing template. So I'll put a null on it, and on the actor for my boxes, I'll turn on instancing on the instance page, and then drag the sub onto the instance chop.sub parameter. And now I can choose P0, P1, and P2 as my transform parameters here.
Could you go a little bit slower this time?
Oh, sure, yes. Sorry. I actually don't need Z because that's not changing. And I think I have to initialize the actor for it actually to pick up the instancing. Yeah. So now you can try again running this bullet solver, and what you get is, wow. Wouldn't have expected that. I mean, just the performance dropping like that. But
Mine drops down to 30, but it stays there.
sorry, there, or no question. So you can see that these boxes are now acting as dynamic actors as well, because we hadn't changed that yet. And perhaps that's something we should change, because these boxes shouldn't interact with the system as this. We don't need them to be falling down, but we actually just want them to be static. So let's change the actor on the setup page from dynamic to static. But let's also give them a restitution of 1 so that the ball can retain its forces, its energy when hitting them.
What happens if we set the restriction to a value higher than 1?
Restitution?
Yes.
Yeah, when you set restitution with if you try this with the pedal here, let me just take this out of, if you set the pedal actor, where the pedal here, I set the restitution to 1.5. So what happens is that this is still being picked up. It's not rendered, but it's active. I have to actually turn the active off. What happens is that it's just getting faster and faster. Being there. and it disappears. Always at the same spot. It's amazing. Alright, so I'll put those boxes back in and turn them on to be part of the system. And maybe I should move this actor down a little bit so that it's not starting inside the inside my boxes. So yeah, let's just move it down a bit to y minus 2. Stuck. Very nice. I'll set the actor, the restitution of the, I'll set the restitution of the pedal back to 1, just to keep everything sane. So maybe my first step would be, how can I move the pedal around? Like, the pedal is currently pretty stuck. And I learned something about this, what they called name gone. What do you do in Star Trek when you move people from one place to another?
Teleport?
Teleport. Yeah. Basically, you're teleporting. If you're moving this transform here, like my first approach would be, okay, I can now take my mouse and use that to transform the actor such as this. But apparently this is seen as teleporting this actor around, and the problem being that it then is outside the system almost. It's being moved outside the system and not properly then calculated. So how can I deal with this? Well, I can take via the bullet, similar to this bullet solver, or the same as this bullet solver chop. Let's take another bullet solver chop. Oops, sorry. And let's reference our actor, which is the pedal, to the bullet solver. And now what I can do is I can override this TX function with my mouse position. This TX would be overwritten with my mouse function, or with my mouse position. Now we have a multi-screen monitor. Let's see, I'll just try taking a mouse in, which goes from 1 to -1, perfect, -1 to 1. So I'm using a mouse chop, and I'm just going to grab the TX for now. You could set this up with a panel. I'm not going to go through the effort now to set this up with a panel. And then we can use the replace chop to replace the TX that's coming from the pedal with my TX coming from the mouse. Replace. Pipe in the mouse chop as the second input to the replace. And then we'll put a null chop at the end. And now, as I explained to you earlier, we can override properties or channels of this actor via the feedback chop here, the feedback chop parameter. So I can take this null 4, drag it onto the feedback chop, and when I start my system, I can actually move this thing around. Yeah, and this is probably what I want to do now. I want to change the range of this TX to fit my screen here. So let's add in a math chop and change it from -1 to 1 would be -8 to 8 or so. And now I can already play a little bit here. That's unfair, because I didn't plan for game logic to actually to prevent that we can get the ball stuck under the pedal. We can just move the actor, this pedal, a little bit down. That might be a good idea. So let's translate that a little bit more. All right.
Range was from -1 to 1, or?
Yeah, minus from range is -1 to 1, and to range is -8 to 8. So having done that, my next task would be, I want to see which of these blocks is colliding with my ball. And I can retrieve that information also with the bullet solver chop. So let's place another bullet solver chop right beside our grid of little boxes here. Get a bullet solver, drag the actor that holds these boxes onto the bullet solver. And you see now I get, instead of just one sample for my pedal, like I have in my pedal here, I get a sample for every actor. And what I particularly am interested in is the collision info. So I want to know which actor is colliding with the ball, or if one of them is colliding. So I have this colliding channel here. What I don't really need is any rotation, scale, or velocity information, but I want to retain the translate information, because I currently don't have the option to remove one of those instances from the system. If the ball hits the system, in other environments you would say delete this actor from the scene. I cannot do this here. As soon as I would delete one of those instances, actually the system would be out of date. So the workaround for this is that I will be using TX again, and every time it's colliding, I'm just going to add a weird number like 8,000 to that actor's TX position, feed that back, and it should disappear.
Would TZ be better than TX?
Doesn't really matter. Yeah, I mean,
You're just getting rid of it.
just getting rid of it by putting it into limbo, into, yeah, never to be seen again land. Okay. So what information do I need? I need the colliding channel. Perhaps we should have a look at the colliding channel to see how that is behaving. So I'll just put a select chop there and select the colliding channel.
I don't have a collision. Oh, collision info.
Yeah, in the bullet solver, turn on collision info. And now start the simulation here. And that's unfortunate. Maybe I should give it a little bit more initial velocity. I could give it a little bit of, I can give the ball a little bit of initial velocity so that it's going up first and maybe to this, yeah, a little bit sideways and 1.5 up. So let's try that. Nope.
Where is initial velocity? Oh, it's just linear velocity?
The linear velocity, I thought I could give it an initial value there, but that's not enough. Let me see what I set that to. Okay, I set it to 8 and 1, so a little bit higher values. It's something to play around with when And I don't see the colliding channel go off, so I have to check again. I probably missed some step here. 1 second. What is this complaining about? Oh, enable perform contact test on bullet solver chop in order to track collision information. So I would have to, luckily I get a couple warnings here. So I have to go to the bullet solver comp and turn on track perform contact test here. Yeah, and now I see I get these pulses in my colliding channel. And the one that's colliding is basically I have this one long channel with all the samples for each actor is one sample. And what I want to do now is I found out, and this is a little bit weird, I found out that if I remove them right away, like as I had planned, I can just say that instead from 0 to 1 for this colliding information, I'll put a mass chop on it and scale this up to 8000 and then add it to TX so that every time it's colliding, I'm just throwing it out into space. And then I thought, great, I'll rename it to TX. To TX. And then I take the original TX. So I have to make another select chop here. I middle mouse clicked on the output of the bullet solver chop, pull out the TX channel, and now I add them together. Combine chops add. So every time now the collision, I get a collision event, it multiplies that 0 to 1 value by 8000. I get 8000. I'll add that back onto its original position.
What did you pull out? Was it total collisions?
Colliding down here and up here TX.
Oh, TX.
It's, yeah, TX position.
Oh.
And now what I have to do is I have to replace the original TX channel with the new TX channel.
I'm getting TX and TX1 out of this math.
So if you get TX and TX1, then in the math, choose combine chops add.
Combine chops add, okay.
Yeah.
But are you getting a TX from the solver? No.
And you're getting a TX from the solver. I turned off rotate scale and velocities, but I kept translate.
That's momentary. But it's still the TX of all the boxes, right?
Of all of them, yeah. But because the colliding gives a pulse
Peak
only where it's for the ones that it's colliding. And now to replace the TX channel from the bullet solver with the new TX channel that I calculated, I'll use a replace chop again, just the same as we did here. So middle mouse click on the output of the bullet solver, find the replace chop, and replace the original TX channel with the new TX channel. Append a null. And reference this null as the feedback chop on the actor. So let's see what happens now. Initialize everything and start simulation. It's actually good. Wow. On my computer, and this depends on, I wonder, does anybody of you have a computer where the ball just goes through all of the blocks, or does it delete them properly? Oh, yeah. That is perhaps an issue.
how do we get more velocity in the ball?
More velocity, right. So the next step would be that. I mean, you can always increase the... what I basically would do here is I don't want to add velocity whenever it hits something, but what I want to try to do is limit or clamp the lowest velocity that it can be. And I would follow the same idea as I did with these other networks here. So,
may I ask one thing again?
Sure.
I don't know why my the thing in the bottom is not moving, even though I put the feedback shock
from the null 4 to the
yeah.
to the feedback, and you get the mouse. What's your mouse values returning?
Yeah, the mouse is yeah, the mouse is and then
But then, no, we don't, this needs to be fixed totally.
sorry? Yeah, but that,
Is that a rolling friction thing?
I think so, yeah. But the rolling friction is really funny. You need like
still,
tiny values. I'm confused about this parameter here.
yeah, and then it should be minus.
Yeah, so it's you can just check the help and see if there's more information on the rolling friction. And what it says about it. The rolling friction of the actor. Resistance drag of one body rolling on another.
Yeah.
So that should be the right one.
Yeah, yeah, I should try it.
But yeah.
Yeah.
Any questions while we wait for a second? Or does that make sense so far?
Can you do particles?
Very, very little amount of particles.
That's all on CPU?
Yes. Yeah. Yep. So I mean, if you want to try already, it might be a good chance for you to try to clamp the velocity. How you would do that? How you can clamp like have a minimum velocity of 8 or something like that.
Yeah, but when I clamped it and set it to like -3 was like so.
Right, you have to do a little bit of math for that, but it's all in. Basically, what you could do is you calculate the length of the velocity vector with the mass chop, which has a length, and then you limit that at a minimum, and then you divide the velocity that it currently has, the length of the vector that it currently has, by the clamp version, and you get a multiplier which you apply to the original 3 velocities, and then you retain directions basically. But we'll do that.
Okay, we'll just watch.
So the actual breakout game doesn't really have gravity, and it just has a continuous force.
Because no one
Almost like playing billiards or something, where it's constantly.
Right. Actually, you know what? That's one of the reasons why this is stopping quite quickly. I didn't turn off the use global gravity on the ball. If you do that, you retain.
But that's how we
That kind of stuff happens to me quite a bit.
Yeah, but then it just makes it go perfectly sideways.
Yeah, and then you gotta wait. And there's some weird angles, but not quite sure yet. So yeah, what you need for the velocity, grab these three velocity values, velocity tx, ty, tz, with a select chop. And this is the bullet solver that the bullet solver chop that we earlier attached to the actor of the ball. So select velocity tx, ty, tz, and you can calculate the length of that vector, basically, like the total velocity, so to say, via a math chop, and going into combined channels, and there's a length option here. Now I want to retain a velocity of something like 8, or at least the initial velocity that I gave it here. So let's say 8. And so I'm going to add a limit chop. And on the limit chop, select as type clamp, and set the minimum to 8 and the maximum to, I don't know, 20. And now when you divide the velocity, the minimum velocity that you have here, via a math chop, with the velocity that the ball currently has, math, combined chops, divide, you get a multiplier, which you can use to multiply the velocity in all three directions with. So middle mouse click onto the select and get a math again.
What's the first math doing?
The first math here is combining the channels and calculating the length. So you give it a 3-part vector, and you basically get the length of that vector. So I'm adding another math and choosing combine chops multiply, combine the original velocity with the new calculated velocity, append a null chop, and feed that back into the actor as the feedback chop.
What does math 6 do again?
And the math 6 multiplies the original velocity with the multiplier from the math 5. So it's a combined chop multiply.
It multiplies to all three.
To all three, yeah. So
Not
you
only tx to tx.
so you get the you retain the direction, because you basically in all if you have 2 directions basically, and then you append the same multiplier onto both, then they scale equally. So the direction of the vector.
Are they going to be on the
The mistake I just did is I'm just using this null 6 as the feedback chop, and the null 6 only has the velocity in it. But as with everything, I have to feed back also the position and everything else. So I have to use again what I did down here, a replace chop, and replace these velocity values with the bullet solver. So replace second input be the mass 6, and now the null 6 goes back as the feedback chop to the actor. So if we would do a little bit more naming here, this would be mass vector length limit minimum velocity velocity multiplier and scale velocity. And now starting this system here, you should you can see that the velocity sometimes is above 1 because it's trying to keep it at a minimum of 8. Any questions? Does that make sense in a way? You have a couple more components that I didn't step through now, which would be force and impulse force. So impulse force is a force that you can momentarily, like you can basically, if you have something moving to space and you give it an impulse force, then for this one moment it would get a boost, essentially. While force would be a regular, like a constant force. And constraints is so that you can constrain actors to each other. What I would also, recommend doing is you can now right-click onto these operators in the op-create dialog, and if there's a snippet, you can go to the snippets. And this is ridiculous, we don't have snippets? What? Get out of here. They're in here? Yeah, I just thought we had. Oh, it also has they're all under the bullet solver. Okay. So if you open up the snippets or go to the op-create dialog and on the bullet solver, right-click and open up the snippets, then what you will get is a lot of examples for these different types of bullet solver situations. So you have a very simple one, like just a bouncing ball. There's friction. There's the instancing example that we basically also went through. There's impulse forces, like shooting something through. Start. So you see I'm starting the simulation. It's already running, but I have to apply the force to actually shoot it down into the floor. Various examples of other forces. Bridge constraint comp with hinges. So you can do these kind of things with constraints. Similar constraint example, but with a ball hanging on a chain. There's driving a car, etc., feedbacking, and
What about reconstituting something?
Like re-emerging it, or you can always initialize these.
What what if you wanted to blend it back? Like you destroy the tower and then have it kind of reattract to a shape.
Go back, yeah, there's an example here as well. It works via the feedback chop as well. And do I have the snippet still open? Nope.
You could just probably take a snapshot of the
Operator
feedback
snippets.
cross them.
That's a recycler. Turbulence. Oh, here we go. Here you have basically where you drive the that's better. Snippets of snippets, that doesn't make sense. Oh no. Here we go. Start simulation. So such as this, right?
This is only the op snippet.
It's in the op snippets, yeah. Yeah. Blending, some filtering, and feeding it back. Any other questions? I hope this helped. I'm sure you will see. Oh, yeah.
Are they also instanced on the GPU? Those?
The instancing is done on the GPU. Yeah.
So they are instanced on the GPU. So if even though if you are using 1,000 or 10,000, it should be okay.
Well, so the instancing is done on the GPU, but the simulation itself runs on the CPU.
Yeah,
so you're still, bound on that. Yeah. There's work being done on making this multi-threaded, so that should increase it quite a bit. Yeah. But yeah, more to come, I hope. Interesting, I have to view this. That's a nice bug. If I turn the viewer off, it stops. Alright. That's how it is. That's how Greg forces everybody to have open viewers. Just make them not work. Yeah, I guess we're going to the next part now.
Yeah, well, the next part is basically whatever questions you have.